the meeting également.
Good morning, Master. So, good morning, Master. Oh, Uma udah ada sketch harga cash postulan sarlan. Gini aja jelas. Lela tak tahu ini. Lela yang tinggal susah di tahu ini. Uma video setting susah link par gini kan dia.
Ancaman ni berikut.
Lela tak tahu.
Ini lah thong ni titik lah.
Udah susah lagi jelas.
Good morning, Doctor. Are you ready? Should I start, Dr. Jimmy?
Yes, Doctor.
Okay. Good morning, everybody. Good morning and good Zambola. And good morning, good afternoon, wherever we are. I see a couple of our friends from outside the country. So we need to see, probably we are from this region. Maybe good morning to everybody. So I would like to, on behalf of the college and the team, I would like to welcome the participants to this crash course on R. This is a one-day long R training, because nowadays the use of R software, the R software and different tools that is available in the R has become very popular. It is gaining momentum, but also we need to also think about the connectivity issues, how we can actually conduct this kind of training, online training, effectively. To many of us, I think our software has really become the necessary, and we really need to learn this somehow. Data that is available with us. And another thing is, nowadays online training has become really popular, although how effective they are, it's very difficult to say at times. The effectiveness of the training is something that we need to think about quite critically. In a short notice, this time we are organizing this training in a short notice. We are conducting this as an experiment. Just to make sure that this becomes effective. And if the pandemic, the problem of this pandemic continues, then we need to organize this kind of training in the future. So how we can be effective, and also to figure out what is the need of the clients actually. So at the end of the training, what we will do is we will share the feedback with you, and we would like to request all of you to provide the feedback so that we can help each other in delivering the training. And then you would also be benefited with the kind of training that we provide. And I think you would be surprised if I say that you learn R, using R software and then analyzing data. If I say that you learn in a day, you would be very much surprised. And I think people have been working with this software for ages actually, and then they're still learning and trying to figure out how best they can use it. But today, what we will do is quickly, at the end of this opening, I would request Dr. Jigme to go to today's schedule. But in short, what I would like to share with the participants here is that as an experiment, we would like to show you how we can use the R. And then basically, if you have specific kind of issues, probably share with us. Probably many of you would already know quite a lot about the R software. And in that case, we'd also appreciate your feedback, how we can actually incorporate and then make this training as efficient. So in future, from this learning, what we are intending to do is offer this training as a package, organize specific training for 3 days, 2 days, like that. So that's our intention, and we would look forward to have your feedback, hear from you, and then improve our delivery so that both of us can help each other. I mean, all of us can help each other in a way, delivering and then learning this software. And thank you everybody for finding time to join this. And this, I think as of now, we received more than 300 participants, we looked at the registration list, and then we see that there are more than 300 participants actually. People are still registering. I don't know how many participants this Zoom can allow us. I think the connectivity issue that I talked before is something that we need to think about. But we'll try our best to offer you the best of what we can. And once again, thank you, everybody. And then I really hope that you will gain something out of this training. And then we look forward to see you in the future as well. So for today's session, I would like to wish all of us good luck, since this is a April Fool Day. I hope we will not be fooling people. So anyways, so we are starting the good day. Today is the April 1st. So we are starting this one. So we are looking forward to have fruitful discussions, fruitful collaborations in the future. So good luck to everybody. So with this, I'd like to hand over the floor to Dr. Signy. The floor is yours. Now, would you quickly run the today's schedule, and then after that start the session?
Last Doctor, thank you. So I will just share the today's schedule. This is the actually the tentative schedule. So we have done with the introduction by the drill, and we would like to thank Doctor for spearheading this program. And so first we have for today's schedule, we have data preparation and introduction, and I would be talking about that. And we have today's crash course major chunk. We have data exploratory data analysis, so that actually major chunk will deal with that. And in the afternoon, from 3:15 to 4:30, we have introduction to inferential statistics. I will probably, if time permits, we would like to cover more, but I think due to limited time, I think we won't be able to cover everything. So we'll be covering some of the inferential statistics. And I think we should begin, Mola, Doctor.
Yes.
Let's first.
Sorry.
Yes, Doctor.
Probably introduce yourself and the team.
Yeah. I think that is required. My name is Jigme Tenzin, and I'm working as a lecturer here in College of Natural Resources, and I'm also serving as the head of the Department of Animal Science. If Ugen sir is here, I'm not sure whether he is here or not. So if
Doctor, I'm here.
Yeah, okay. Please introduce yourself.
Hello everyone. My name is Ugen Ruji. I'm from Bhutan. I'm from Tashigang, and it's been around 7 years working in CNR, and I'm currently in Department of Forest Science. And I've been teaching R for quite some time, doing some training, statistical analysis training. Thank you so much for showing your interest. We look forward to have a very good R session. Thank you so much. We have a very long session today, exploratory. Thank you.
Lester, thank you so much. And I think we'll begin our session. And so maybe I will take you through. I have sent the links for installation, but maybe I will just quickly run through where to get the software. So I'm sharing my screen. I hope everyone can see. So maybe just you can search CRAN. If you can hear me, if you cannot hear me also, please let me know. So you could go into this CRAN, like CRAN. And you could just click this first link, like CRAN. And we can download the R, the base R from here. For example, mine is for the Windows. So I have sent you the link for this tool, these two, base R and R tools. So you have to download this as well as this. So if you haven't downloaded, please do this, base R, and you can download for Windows, or R tools you could download for Windows. So as well as you could also download for Mac. So you have for the Mac, and you could download from here. So I'm not using Mac. So if you're using Mac, you have from here. And if somebody is using for the Linux version, so you have here. And there are so many distribution in the Linux circle. So Debian, Fedora, Red Hat, and Ubuntu. So you could do that. I'm hoping that many of us actually have downloaded this one. And now I think let's go into actually the R. So then again, I forgot one is we should be, I'll share screen again. So what you have to do is you have to install the R Studio. So you have to search the R Studio, and R Studio, you will search in the Google, and you have this R Studio. You can directly click this download actually, and download this R Studio. Okay, so you could download this R Studio, and I'm hoping that many of us have actually downloaded and installed these three tools: base R, and then R tools and R Studio. The most of the work we'll be doing in R Studio. R Studio is also called as integrated development environment. And if you the environment that we use will be, I think, easier to use. For example, if you use the base R, just base R, it is very difficult to work in. So in that case, now we are trying to use R Studio. So I hope you have downloaded and installed these three things. So we'll be using only the R Studio. So I'm going to share the screen for my the R Studio. So you can also maybe follow along with me. So I'm going to share the R Studio. So if you can see my R Studio environment, because it might look very different to you. I have changed some themes, and it will look different to yours. So I hope you have installed this R and R tools and R Studio. Okay. And if you are not understanding, or if you want me to repeat when we go through the introduction session, please maybe raise your hands, or maybe you could drop in a message on the chat box. So now what we will do is we want to look at the interface. This is actually the script file. The one I'm using is the script file. You could go to this file, create new file, and go to R script, and you will get a script, and you can save this. Actually, if you do Control S, you could save this script into any directory. So what we will do is I have just prepared one script, and this is the script I'm having for the interface. So this is called the script email. So it is the script the environment, and you have there here console, and you have here environment, and you have around here all the files that you will have, as well as you have the viewer, and also their plots and all. It will come here, and help panel is there here. And usually in R we work with packages, so we have packages here, and also other plots. The plots will come here, but if you have other interactive things will come in viewer email. So most of the files you have will come here. And when I write in the script file, if I do the Control Enter, it will run here in the console. So what we'll do is, because I say R is a giant calculator. Actually, R is a giant calculator. If you do just 8 plus 5, and if you do Control Enter, so you can see down there in the console, if you're following with me, so in the console, you could see that 8 plus 5 is 13. So basic math. And also, if you're on Mac, you Command Enter will give you the result. And if you're in Windows, Control Enter will give you the result. And also, if you want to have some series of numbers printed across several lines, for example, 1:250, actually you could get it like. So if you see the console here, you could get the numbers serially from 1 to 250. So I'll just remove this one, and also you can print something called as characters. So print hello world. If you print this, you can also print hello world. And most of the time in statistics, we will be working with variables. So most of the times we'll be working with variables. So variables, actually you can assign these variables to some names, and this is the assignment operator. This greater than sign and less than greater than sign, or like let's say X is less than some minus sign, but this is called as assignment operator. I hope you can see it. This is called assignment operator. I'm assigning actually this number sequence of number from 1 to 5 to variable X. So I'll just Control Enter. And if you have to display this variable, displays this variable in X, I'll just do Control X. Okay. So if you are following along with me, just to print this result, if you you can store your numbers, or we call it vectors in R. So these vectors you can store in object called as X, and that you can actually print by just giving the comment X. And also this, again, you could have something like this, like Y, and you assign this Y to X, Y could be any kind of variable, maybe measuring, you are measuring height, or here maybe you are measuring some kind of weight. So this could be anything. So you could just, this C is also called as concatenate, or sometimes you could just say it as combine. You want to combine these numbers. Here, you want to combine the numbers from 6, 7, 8, 9, 10 up to 10 or 6, or just you could say something like this, 6 to 10. And if you want to print this Y, so just say Y 6, 7. You can, they have given some index, and most of the time in R you'll get this index number in the beginning, just that specify the rows. And also you could do something really silly as this as well. You could just you could use equal, but sometimes it might give you problems. So you could use this equal sign, but mostly in R you should be using this less than and minus sign to assign the numbers. And you could also be silly and use A and assign A to 2, but this works, but probably it is not advisable to use this. So, and in R we never use that, but you could use it if you can print this one. And also you could do multiple assignments, like you could assign everything to 3, right? So you could use multiple assignments. And if you just let's say this, what C is storing, so C is storing 3. So in that case you could do that, but the normal, the style is writing or assigning the variables in this way. And you could do some math here. So you can also do math, so some vector math. So you have X as 1, 2, 3, 4, 5, and Y you have 6, 7, 8, 9. And if you want to add all these things, you just say X plus Y, and it will give you all this multiplication by column wise. So they go individually and iterate. And you can also multiply each element in X by 2. So you get the result. So this is some of the basics. And another one I think we have to cover is, I have here. So I hope you understood this. If you have any question, please let me know. So what we'll do is we have, so next what we'll do is, so we want to install some packages. R relies on most of the package. So it relies heavily on packages. So if you are coming from like less.
Hello, sir.
Sushla.
Sir, nga shirok shudula tatu jamchi lejumbe join besuchi tiani bo the tajigula magi sukhara miss bide isagi.
So maybe I will just quickly run over. So we said that I said that this is a giant calculator. R is a giant calculator. We can just use plus minus 8 plus 5, 8 divided by 5, 8 into 8 multiplied by 5. You could do anything here. And you could do basic math, and as well as you could do this control enter. If I have to run this one, I'll just go here and control enter, and it will give you the result down there and in the console. And if you print this hello world, and hello world is printed down there, and it is these are called string, or in R specifically we call it as characters. And so most of the time you work with variables. So variables, it can be in terms of height. For example, I could just say that maybe this is the height of the plants. So I could say I'm storing this as height of the plants, and I could just say, okay, this is height of the plants. And I could display this height as height, and you could get 1, 2, 3, 4, 5. Maybe that is in centimeter. I'm not sure what could be the variable, but let's say it is the height of some plants, and it is like 2 centimeter, 3 centimeter. You could record in that way, as well as if this is the weight of something, let's say, and I'm assigning and I'm combining with. This is assignment operator, and this C is also called as concatenate, but for remembrance, you could say it is combine. So combine, and maybe this is a first individual, second individual, third individual, fourth individual, fifth individual. So you have actually collected data on some weight of, I'm not sure, but it could be anything more. And what you could do is here, you could say weight, and you could actually get the print. And you could use, let's say, equal also. Sometimes in other programming languages, like Python, you might see equal, but here in R specifically, we use this assignment operator. So you could assign, and in opposite way also you could assign it, but especially it is not really used. And but also if you have like some values that is equal to 3, A, B, C, D, maybe the first person is equal to second person and equal to third person, and they have a value of 3, so you could assign in similar way, and you could get A as 3, C as 3, and you could get everything as such. So, and also I was saying that this if you have this weight and combined together, this is called as vectors in R. So you could also do vector math, and we have this X and Y, and you could just plus, or you could multiply, as well as you could do any mathematical operation that is needed here. I hope that is understood, and quickly we'll go into how to install packages. So installing packages. So how to actually library will bring up the list of installed packages. Library if you just type this one, library, it will bring up all the installed packages. So I'll just do Control Enter, and it would bring up all the installed packages that is there. All the installed packages, for example, you have ABIND, SPAC, SCS, everything, it will load. And if you want to see what are the packages that has been loaded now, you will do search. So here you have, for now, I have global environment, RStudio, RState, utils, autoloads, methods. These are all loaded email. So these are all loaded, and you could see them. And if you can see this, actually, I didn't say earlier, but this is our called comments. So these are called comments, and it will be a comment is done by having a hash in front, and you write whatever you want to write here. So this will be not part of the code, but as a part of your, as part of the explanation. Actually, you want to remember what this actually the library does, then you have some comments here. Actually, you want to maybe assign something to number 5, then you would have like a comment saying assign 5 to X, maybe something like that. So that is the comment. And these are actually called as functions in R, and R is usually reliant on these functions, heavily reliant on functions to execute many of the statistical functions. And so to install or use package, what you will do is you could go to tools, actually tools, if you have RStudio installed, so you could go to tools and you could find that there is an install. But in R, it is really easy, and usually in R we use the command called as install.packages. So if you look at it here, so you have like the command is install.packages. Install.packages, and you want to install ggplot2. This is called as grammar of graphics plot2, and it is heavily used in visualizing. So visualization, and for example, there is a package called as car. Maybe there is a package called car. You could install that as well. So let's try to install some package. If you are following along with me, let's try to install some package. So ggplot2 I have installed, but I will just run this Control Enter install.package, and you will need this quotation mark from install.packages bracket, and you have this quotation marks. So you need to have this. It is now installing. So this ggplot is now installing in the library. Okay. So if you really want to look at how this works, you can get the help page as well as install.packages. Install.packages, and here you will get all the description how how you would do it. So install.packages and package name. And most of the time, I have never used such like get option. There are so many things here, but I have never used it. So what you will do is install.packages and use this to install any packages, because most of the time you will be using these packages to actually visualize as well as do modeling in R. So to really use this library, actually you have installed, but by default it will not load into the your to just use this ggplot. Actually, if I have to use this ggplot function, if I say ggplot, and if I maybe use some data, let's say mpg. So if I want to use this data, so it will say that there is error in ggplot2, could not find function ggplot. So we have installed, but we are not finding that function of ggplot. So what we need to do now is actually load that library, load the library. So load the library, and we'll say library, and you could use this quotation mark to load this library, ggplot2. You could load this library, or sometimes you could use library, just library and ggplot2. However, most of the time, when you install this one, this quotation mark is required, but for calling out the library, you could either use this, or so it could be or, so you could use both. Okay, and if you really want help, you could just also say ggplot. If you want to use ggplot2, so you could say ggplot2, and so how to use, you will get it here. So everything that you want to learn will be here. So it is, I think, developed by Hadley Wickham and team, and you could visit his website actually, and he has also some book on ggplot2. So this is how you will install the package and also load the package to use. So for example, so to just use the ggplot2, so I will say ggplot. Now I can use the ggplot2. I'm giving some data. This in details later in some, I think in the exploratory data analysis, you will know it, but I'm just maybe let's say X is, I'm not sure. Let's just see the structure of this data, actually, structure of MPG data. And if you have to have some plot out of this, I would say aesthetic. This will be taught later, but I'm just showing you how we could do it. So X is, let's say, city, and another is highway, just a rough plot. And what we will do is plus, we will say maybe geom, let's say point. This will be done in later classes, but so you could see here, you could get a very beautiful plot. I do not know how that is useful now, but this will be taught later on. So now we can use the function. I just want to show how you are using that function here. So first install the package, then load the package. This is important step, load the package. Install the package first, load the package. And if you have to use the function such as ggplot, you will have to install as well as load and use this package. So I hope that is clear. If it is not clear, please stop me anywhere. And after, because you want to, you have installed and sometimes new. Yes, La.
Excuse me. Sir, install baby tools.
So
Either-
what is the specific problem you are facing? Actually, you really have to write this way: install.packages, then quotation mark. Inside, then you write ggplot2.
That's such types.
You will need R will not accept. If I just say like install.package, also it will not work. I'm getting error. And if I install.packages, okay, this is correct. But if I say something like this, and there is no quotation mark, ggplot2, if I say ggplot2, it will not work. Error in install.packages, object ggplot2 not found. If you look at here, so it will not work.
Yes.
So were you able to install it? Maybe this is really important, so maybe some of you could try and let me know if it works or not work. If you're trying.
It's working, sir. Thank you.
Okay. So in R, usually there are data sets. Okay, data sets. Let's we said question mark, we look into data set, built-in data sets. We have so many data sets. You could look at data sets, look in data sets. And this has package contain variety of data sets. So what you can do is now, if you want to load that data set, what you'll do is you'll say library. Okay. Actually, every data set will be loaded from here if you are loading the data sets. Okay. And if you want to use some data from here, you would say data. I'm from the Department of Animal Science, so I would use something known as, there is a data known as chick weights. For example, here, data chick weights. No, I will load this data known as chick weights. Okay, I hope you are able to follow along with me. So data chick weights, and if I have loaded that, I could see the structure actually, str, structure is me. So they use it, use the function on this structure. So if I look at this chick weight data, it is a data frame. So data frame, I have not covered this, but usually it is a rectangular data that is there. You would always, your variables will be in the column and your observation will be in the rows. So that is actually the data frame. And if you really want to view how this looks, so this data frame, how it looks, I could just say view the, it should be capital because it will not work. It should be capital and view chick weights. If you control enter, so it will open in new tab, and it has weight and feet. So some weight is there and there is feet, different kinds of feet, and they were comparing maybe how it differs in weight when you are feeding horse bean, linseed. So this is how it is done. So next, what we will do is, I think we have learned how to, but maybe just if you really have to enter some data, you could do like this. X1, 0 to 10, you could assign this one, manually entering data. I think I have told you that earlier as well, but maybe just as a recap, you could, if somebody is joining now, so you have 0 to 10, X1, 0 to 10, maybe this could be any variable that you have interested, and you could 10 to 0 as well. It will go from 10 to 0 serially. If you look at it, 10, 9, 8, 7. And you could also use this sequence function and say it is the X3 variable. The variable is from sequence of 1 to 10. And if you look at it, this one, X3, so it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it works in both ways. So you can use this function sequence, sec, just use 3 letters, and you could use this as well as you could just write from 0 to 10, or if you want from 1 to 10, also you could say 1 to 10. And if you look at it, it is 1 to 10. So what we will do is next, try to load some data. Actually, we will try to load some data, especially in doing any statistical work. You will have actually some Excel files, or text files, CSV, comma separated values, or tab delimited values. Mostly. So what we will do is now, if you have some files you want to import, so if you have some files you want to import, now we can use this function. Actually, I'll just maybe delete this, and you're going to bring in some data, let's say data, and you can store this into object. Actually, this could be my name as well, right? Jigme, for example. I can say Jigme. Maybe I could say this is a data. I want to bring in some data and assign and read.table. So read.table is one function that you want to read. And if you have file in the form of, let's say, now I have a file called Google Trends. If you have any file that is in text format, you would have Google Trends. For example, I have files like Google Text, right? Google Text. So what we will do is, I will say, I'll copy paste because I don't want to. So you would have this function, actually read.table, and actually this is the path. This is the path. This one, if I will write it here. This is the path. Read.table, and this should be the path. That path is actually the location. So the location is here. So this is the location. Okay, this is the location. Read.table, and we want to read the text file, and we are giving the path it says C, user, Jigme, desktop, R, crash course, lecture, and so many things, and the specific file, and it is the text file. And I am saying there is a comma here, and header equal to true, and separator equal to tab. So tab is given as such. So if I say Control Enter, so that data is actually read. If nothing happens, that data is actually read. So now, mistakenly, what I have done is I have assigned this to data as well as trends.txt. So it should be working in both, but I'll remove one. So I'll remove one and let's run it again. So I'll just remove this and trends.txt. So now actually you can view what is there, right? Trends. I said you can view, and you have the data here. Okay, you have the data here. Or you could just see the structure, trends.txt. This will be dealt in detail when you have the exploratory data analysis, but just as a warm-up, I'm doing this. So you could have this in the exploratory data analysis. You will learn how to read from Excel file as well. I think that is the most important one. But before that, maybe we will also look at how to import from CSV file. Because typing takes time, so I'll just copy paste here. And similar thing. So because the separator is comma, so you don't have to specify anything. You have just read.csv, so comma separate value, and we are giving some path. This path, and this is the path, and we are saying there is a header, and there is a header, and it is equal to true. So same thing here. If you look at it, trends.csv, and you want to look at the structure. So trends.csv, Control Enter, and same thing. You are getting the same data here in here. So same data is saved as text file as well as CSV file. So I hope this introduction was useful. If you have any specific questions you want to, I think maybe some doubts are there. Maybe I will take some time to fill your questions. If you want to clarify something and you want to know some specific things, please let me know. If you want to try uploading some files, you could do that. If you have in CSV, I hope many of you have data in CSV. So if you have, you could try that, but if you don't have also, no problem. So this to read Excel file. So next speaker will continue with that, I guess. So any questions?
Doctor, there is a question in the chat box. The question is, how do we clear defined variables?
How do we clear on the environment?
Defined variables.
Yeah. How do we define variables?
How do we clear defined variables?
Oh, yeah, you could do something like this. Remove RM remove x3. For example, you want to remove this x3. Actually, if you now come down here and say x3 not found, actually now you have removed. And if you want to remove x2, you could just do that, remove x2. So first, let's see x2 is there or not. So x2 is there. So I'll say remove rm and x2, and let's see whether x2 is there or not. Okay, so x2 is not found. So any any other questions? Actually, I cannot see the chat box. I'm not sure. I'm not really familiar with the usage of Zoom, I guess. I cannot see the chat box.
Good afternoon, sir. Good morning.
Yes.
The question is, I meant, how do you remove all defined variables, sir?
From
All
the
at
environment?
once. Yes, yes.
From the environment?
Yes, sir.
Okay, so what you will do is remove. So you would say something like this, list equal to, so I think this should be removing everything. So everything is removed. Actually, this is the script file. So script file, you could save this everything if you have done something like that. But for now, everything is removed from the environment. Actually, if you want to see whether height is there or not now, height. So object is not there. So I would just run everything once. Let's run everything. And you would get everything here in the environment. So you have defined this variable. Now what you will do is, so I'll go up. So just to get this, you can go into variable. And if you have, so you could say remove list equal to ls bracket. So you should write this. So maybe I will keep it in the script. So if you run this, everything will be removed. But this is a script file, so if you really want to remove from here, you have to really delete it from here. But especially it is nowadays the trend is for reproducible research. So if you have some script that has all this information, then you could run it again. I could remove everything from the environment, and if I run it again, so everything comes here in the environment. And to actually run everything, so if you have to run everything here, so everything is defined, okay? So to clear the console, so just maybe I will comment this. And if you want to clear the console, so you would do something. I'm doing Control plus Shift plus L. So if I run from there, so there everything is filled here. If I say Control L, everything will be removed. Control and L or Command L. If you are using Mac, so you would have like CMD something. Any more questions? if you are trying and if you are facing some problem, let us know. Maybe I have few minutes left, or I'm not sure whether my time is up. So I have around few minutes left. So if you have any specific questions.
Hello, sir.
Las Sunshla.
So, what is the use of estimation in ggplot, sir? Can you, if you can explain it clearly, sir? I could not understand that.
Actually, let's library load this one, ggplot2, right? This one will be explained by our next speaker, but just to give you a heads up for next session. So this is library ggplot, and ggplot is actually for a visualization. So this ggplot is a function, ggplot, and it works as a layer actually. I could assign this to plot, then ggplot to ggplot. Then I want to have a data. Actually, some data will be there. I'm taking MPG, right? MPG, and this is actually aesthetic. We write ES, but it is aesthetic. The beautification zumbe me wala. So aesthetic, you want to include aesthetics. So X variable you want to, because I don't remember what is there in this MPG dataset. Let's say MPG structure. I want to model displacement. So let's say I want to see the connection between this displacement and why the mileage of city, mileage of city. I could just run this, and I could, this grammar of graphics, I will just P plus then geom. Actually point is scatter plot. Actually this is scatter plot, and it should be coming. So here maybe the displacement, if it is lower, it is giving higher mileage. So you could see this. So this is actually aesthetic, and you have x-axis displacement, y city. This will be dealt in detail in the next session.
Oh, less. That means aesthetic is used for displaying the XY coordinates, right, sir?
Yes, yes. Also, you could just display one more. For example, you want to display a histogram. Yes. You could just give one variable, highway, and histogram highway, and we will just come here, and maybe the function is histogram. And if I run this to highway, and if I do this, and you could see this histogram, right?
Yes. So what is that geom histogram? Actually, I heard that
this is also geometry. The shapes are geometries, right? Okay. So they describe as geom. In art, they call it as geom. Specifically, this one for ggplot function, they call it as geom, the geometries, and they want to build it up on layers. So they want to build it on layers by layers. You could just specify. Then you could say ggplot highway. Then you could just run this, but you will get empty plots here.
Okay, sir.
Empty plot, no. Then what you need to, layer by layer, thanka painting zumbera. If you have to paint, right? You have a canvas, and on that you have whitewashing, no. That whitewashing there, then you have some color, no. Geom let's say histogram, right? Histogram. So it is like really like painting, actually very versatile.
Yes, sir. That's
Last,
thank you, sir. Thank you, sir.
last one. Any more questions? I have around 6 minutes. But if you have no question, I will give it to our next speaker because he will go through all this.
Last, sir. It will be more clear, sir. Thank you, sir. Thank you, sir.
Last, if Ugen sir is here, if there is no more question, you can take over the session. Ugen sir.
Let's sir.
Kuzambu again, sir. I'm listening, sir. Watching the videos.
Listen, Kuzu, welcome back.
Thank you.
Should I take over now? Doctor?
Yes, of course. Last.
Thanks. Thank you for introducing. Good morning, everyone.
Ugen sir, can I?
Yes.
Maybe just to inform the participants that we will break for lunch from 12 to 1. So it is already 11:10. So we will deliver 1 hour, and after that we will break for lunch, 1 hour lunch, and after that we'll continue. Just to inform the participants. Thank you. Yeah, back to you, Ugen sir.
Yes, Dr. Jimmy, can I use the screen now? Share the screen?
Yes. I will stop.
Okay,
I hope I stopped.
I think you're still on the screen. Please stop sharing. Okay, thank you. Yes. I'd like to share the. Okay. Can everyone see the screen?
Yes, sir.
Okay. Oh. Okay, like great. So can you also see the screen, the next screen that I'm? Can you also see OneNote screen?
Not seeing, sir. Not seeing. Just the R script and the console environment also.
Okay, okay, I'll share this one. I hope now everyone, Professor, seeing
Yes,
this
sir,
one.
yes.
Okay.
Yes,
Once again, good morning to all of you. My name is Sukin Durjila, and I'm a lecturer here at College of Natural Resources. So today, my session will be on exploratory data analysis. So basically, how to explore any data so that we feel comfortable to explore or do test that is coming next to the exploration. So today's 3 to 4 hour session will be how to explore data. This is the schedule of the session. Most of you, I know, you're not clear with setting the working directory. It's very important that we set a very straight, good working directory, and we need to set it well. So I'll quickly run through how to set working directory. Then with the user interface, for example, in my case, my R window is quite blue in color. I've got different kind of script. So I also like participants to enjoy your own R experience. So let us just set user interface. How that one, I would like to install a few of the packages which will be important for us to explore data. Then after that, we'd like to explore data one by one, then descriptive statistics, then overall statistic. We'd like to visualize data in the form of this 4 plots: histogram, bar plot, scatter plot, and box plot. Visualization number 7 will take place through the normal R without installing any package, but there's a grammar of graphics which rightly some of you asked. That's ggplot. So we'd like to spend some time on ggplot. Then the facet of ggplots. So let's just use facets of ggplot again, and cross correlation, and then cross tabulation. So no test will be done in this session. However, next session will be covering all the tests. So I hope we are very clear with the path that we are taking. I'd like to always check when we are working with something else. So first is to set the working directory. So now let us set the working directory. Everyone, get ready. Let's set the working directory. I'll share my, okay. So this is my R script, the console environment, and where I've got the last fourth one where I'll be getting my all the plots, all the files, packages shown there. The first thing was to share the screen. Sorry, stop this. Okay. The first thing was to set the working directory. So you can also do or set the working directory by this function also. But the easiest function, the reason why we are learning R is to make ourselves easy to use R. So let's make it more easy. Let's all go to tools to set the working directory. Let's all go to tools. Let us all go to global options, everyone. Tools, global options. Good, Marshall, are we good? Then let us go to global options, and there you're going to see on the left panel, you're going to see some things like general code console. That's nothing for use right now. You're also going to see our version and default working directory. So we are going to set the default working directory right now. So that means where we can access our data, where we can export our data. That is the working directory. I'm telling you again, the working directory is set to know where we can extract our data from and where we can export our results to. So let us just browse and let us just give one file the working directory. Everyone, please go to the browse. And my working directory was somewhere else, but for today, I'll go to localtext D. I'll go to official, and I'll go to meetings and seminar, and I'll go to R training. So I'll just click the folder. I do not click inside the folder, everyone. Do not click inside the folder. This folder I'll be using as my working directory. And just click open. That means I've set my working directory to localtext C, or localtext D, and to R training. That's the setting of working directory. I'll just apply it, and click it OK. That's it with my setting of working directory. I hope all of you are clear with setting of working directory. So again, let me run again. Go to tools over your menu bar and go to global options. And let us go to the browse over here. And then I'll click this overall folder as my working directory. So in an earlier session, you were talking about read.csv in order to read your data. However, if you are using the working directory over here, you can directly read any file that you have. Just one, I'm setting this one, click it apply, and click it OK. I hope setting of working directory is clear. Let me look at the chat. Are you all clear? Setting of working directory. This should be very clear, everyone. Okay, so I hope, I think few of you are clear. I think most of you are clear by now. So that's it with the working directory. I'd like to now look at the second session. That's with working directory. And sometimes you'll feel that the working directory that you have set may not be working immediately. So if your machine is not cooperating with you, restart. So I'd like you all to restart the program, then your working directory will be set. But most of the time, it should be working now. Okay, that's the first part. Second part is to make your user interface quite cool, the interface that you like. So to do that, again, I'm going to go to my R window here. And to do that, again, we go back to again tools, and we go back to again global options. Everyone, go to tools, global options, and here, we'll just wait for someone to go to global options. Okay, so I hope you're in global options, and we go to appearance. Everyone, we have general, code, console, and there we have got appearance. Go to appearance, and if you want to set exactly like mine, you can use Cobalt. And if you want to change, for example, if you want to make it white, cloudy, dark, you can do that from appearance option. And if you like your font to be a little bit different, like Courier, or I've chosen a Lucida console. So I think for, yes. Okay, so I think for consistency and for all of us to work together, I think let us choose one appearance, Cobalt, everyone. Cobalt, go to Cobalt, C, and editor font, let us choose Lucida console. And theme can be modern or classic. I'll just choose modern. So only these three things, modern, theme, editor font, Lucida, and then we choose Cobalt as our editor theme. That's it. So by default, the font should be 9 or 10. That's fine. So I'll just click apply. And okay, so your whole window should look slightly different now. So I hope you're clear with this one. Anyone who is having doubt? Yes, Jimmy, sir. You can also do this, the same thing in Pack also. Go to tools, no. So it should be proceed, but let's make it very, very clear, everyone. Should we proceed? Okay. All clear from all the participants. Yes, thank you. Now let us again look at our next session. So next session is to install some packages. I think it's very important for us to install some packages. So let's install some packages, the required packages that we'll be using. So we can go back to the share. So let's install a few packages that we'll be using. So this is installation of packages. And if you have written this kind of line, and if you want R to not to read, then in front of installation, you should have hash or the number sign so that R will not read. So if you want R not to read. And another way to make this one is installation of packages for exploratory. And you can also directly click on your keyboard, Control-Shift-C. So that means command, Control-Shift-C. So that becomes directly our command for R to not read. So that's it with making the command. Let us now install a few packages that we need. To install packages, type a function called as install, and as and when you feel that there are two things coming here, install packages, installed packages. We are not going to look at installed packages, but we are going to look at installed packages. So as and when something is coming out, you can either click on your tab button over your keyboard, or you can directly click like this. So this should be working for all of us. And remember, when you are installing packages, the name of the packages are in strings. Like I wrote in command, the thumb rule is that if something is of text or string in nature, always try to use inverted comma. So I'll start with inverted comma. And the first package that I would like to use is, let's see, tidyvers. Tidyvers. So tidyvers is not just a single package, but this has lots of other packages. For example, ggplot that we would like to use, dplyr that we would like to use. This tidyverse has got around 3 or 4 different packages. Then as and when you are done with this one, you can click on the keyboard, Control, Enter. So to install packages, you need internet. So everyone, install packages. I'll install my package here. So it's saying that it's already installed, so I'll not install, but please install in your keys. Install the packages. This is the first package that we need. And second package that we need is install packages, and we may need psych. So this package is mainly for our descriptive statistics, psych. And please note down the spelling, tidyverse, PSYCH. And again, Control Enter. Again, saying that no. So then in install package, we're going to use about 3 or 4 packages. So this is called as core plot, mainly for correlation analysis. Like I said, we would also like to look at correlation. So correlation plots for by core plot. Let's get back to your comments, but let me just finish with installation of last. Let's install the last package, Gmodels. Okay, so meantime you install these ones, I'll just look at the chat. Okay, so first package is tidyverse, and second one is psych, third one is core plot, fourth one is Gmodels. These are the, so try to use inverted comma or quotation mark in order to install these packages. So let me know when you're done. It shouldn't be taking much time. Installation of packages. Yes, great. Great. How can I check if I've installed the packages? Let's just wait. Meantime, I'll just clear Pima. So if you go down to the right button of our R, there are files, plots, packages, help, view here. So in packages, you just look at alphabetical order. If we have installed tidyverse, it's in T, so it should be in tidyverse. RST. Tidyverse is here. So I've just installed tidyverse. And those things which are not checked are not asked. I mean, we need to ask the install packages to now load into the R. So, I mean, the library function that you just have seen in the earlier session, you need to look at the library, then this one. So we'll be doing this one in a while. So do not worry, everyone. Okay. So I hope you're clear. I think you should be clear. I think so. If you have to install the packages, you need internet connection. You do not need a very strong internet connection. You can also do in your hotspots. It's totally fine. Now you need to load the packages. Load the packages. You do not have to take notes on this one. I'll be giving all the notes. Okay. So load the packages. Like I said, to load the packages, you need to use a function called as library. Load the packages. So there are 2 things. One is installation, one is loading. Installation, you need internet. Loading, you do not need internet. So to load, you need a function called as library. So it's saying that this function is in the base R. If you're looking at the curly bracket, it's saying that it's in base R. So it's a free function. And control tab, to load the packages, you can use inverted comma, that's fine. Even if you do not want to install, use inverted comma, that's also fine. I'll just load tidyverse. Okay, it's loaded. Tidyverse is loaded. Then I'll just load, I'll just load, secondly, it's psych. Sorry. Thirdly, I would like to load through library function, core plot. Again, control enter. Then I'd like to lastly load Gmodels. So, okay. So that's it with the loading of the packages. So all the 4 packages are being installed and loaded, and we are ready to go. So, okay. What we'll also do is, meantime, you let the packages load. It's totally fine, but we'll continue because we immediately do not need loading of pack. We immediately do not need the packages. We'll need packages later, towards afternoon or somewhere towards evening. Not right now. So just load right now, or just install it. It'll just install in a while. How many of you are loaded? How many of you installed and loaded your package? Thank you. Thank you, Chandra Sumar. Sorry. Thank you. Thank you. Great. Thank you. Thanks. Thanks. We'll make very clear whatever we learn. I think we're going to make very clear. Thanks. Thanks. Right. So, but for those who are still doing, you can continue. Okay. We have many people, I think, done. Still doing. Okay. So we'll just continue because, like I said, we are not going to straightly use the packages. So in a while, so meantime the packages will load. I'm just going to continue. Okay, we have installed the packages, and then we have loaded the packages. So let us now explore our few data. So let us explore few data. I'll check this one, and now we'll just explore a few of the data. Okay, to explore the data, we are going to now look at exploration of data. Okay, so to make the lines as comment, like I said, Control-Shift-C after you have written, if you want that to be comment. Okay, let's explore data. For our consistency again, let us use common data, though you will be having your own data. But let me just show you one more thing again. Let me just show you one more thing. This is my working folder. I go to official, meetings and seminar. Right now, this folder is the training folder that I have, everyone. This is the folder that I've given as my working directory. Let's say that I've got one data and I want to read that data. Let's say it's, let's get back to dissertation. Let's get back to Sonomyunten. Let's get back to OData. OData, I'll just copy the OData. And let's get back to okay. So this is OData that I've just saved here. This is in CSP right now. So I'll just forget this now, and now go back to share. Okay. To read your data. So I do not need to now do anything else. Let me just straightly read .csv. You can also do it through read.table, how to import. So you can also do through read.csv. If it's CSV file, you are sure that it's CSV file, directly use .csv. But if you're feeling that it's not CSV, but some other file, read.table. So I'm sure that it's CSV. I'll just open like this. Now I do not need to give the file path like local.txt, official, office, seminar meeting, or I directly would like to give the name of my data. So it was O data. .csv. So this is the only thing that I need to do now in order to read my data, so that I bring the data in my script and console here. That's it. Control enter, and the data comes here. So this is the benefit of working with making the working directory as default. So we do not need to now have all the file path mentioned. Please try anything else that if you have any data, then try to read. Specifically, if it is in CSV, try to read the CSV file. So you can explore this one, but this is not my session, so just leave it like that for now. Let us explore the data set that's being given by the R itself, the default data set. So let us just type data and just leave it like this, 2 brackets. And this is just to explore different kinds of data that R has provided by default. I'll just control enter or just run it. And these are the default data set that R has. So it has air passenger data, it has BG sales, it has BOD, COD data, it has so many data, like let's say it has women's data, war break data. So there are lots of default data set that R provides us to practice. So for this class, we'd like to look at data set called as iris. So you just have to type iris. Iris is also one of the default data sets that we have. So you just type iris, then iris should come out in your console. You just type iris, iris should come out in your console. And there's, let me check out the, okay. Okay, sure. Yes, Reliance Digital, we would like to use the default data set. Okay, so we'd like to use iris default data set for our all practice. So let's be consistent. So in earlier class, we saw that we could assign the object to iris. That means, let's say that my data. Let's just type, everyone, my data, and let's just type this figure. It looks like arrow, but it's actually arrow. Everyone, I'm saying again, this is actually arrow, and it's saying that iris is actually my data. So it's defining that iris is my data. It's like showing an arrow that iris is my data. Sometimes people also use equal, but like Dr. Jimmy mentioned, it's not readable if you have to transfer through different softwares, for example, Python and all. So better use this direction. So this direction is called as my data means iris. It's just pointing out that iris is what my data is all about. Now just run it. Run or control enter if you want. Run. And now it's saying that, it's saying in the console that my iris has become my data. The arrow has pointed to my data. So iris is still iris, but you can also use my data as in terms of iris. So let's now see my data, and let's just control it, run it, my data, run it. It's the same results that we are getting in case of iris. So I'll just say in a while the importance or the function of giving data objects to our data, giving the object name to our data. So in a while you'll see why it's very interesting. Okay, so if my data is iris, then let us just view. Everyone, please type view, and you just need to type view. V should be capital, and let's just type my data. So when we are using this function VIEU, there are two functions: small v and bigger V. Bigger V or capital V view my data will give you viewing of your actual data frame here. So Just click view, and here comes the different data that our iris has. So iris has the measurement of basically a measurement of 3 kinds of species of data, followed by the sample length of this species, sample width of this species, petal length, and petal width of these species. So this is how to view. We are just exploring right now. View my data. Everyone, please click on view my data. So if it is not loading, you can always use data, and specifically you want to load iris. This is also one way to load the data. And okay, this is also one way to load the data if it is not by default recognized by our machine. Okay, we have viewed, and when we are using this view command, it goes to the table that we have just seen over here. Let us now look at structure, str structure. So there are 4 or 5 things that you need to look at your data with these 4 or 5 commands. One is view, the second one is structure, and click this one or click directly the tab on your keyboard. And I'd like to look at my data, the structure of my data, and again, run it. And when we are talking about structure, it gives us the actual structure of my data. So my data, which is actually iris, is a data frame. It's a data frame. Data frame, if you are getting confused right now, data frame can be normal Excel table. So that's just data frame for now. It has 150 observation. That means it has 150 rows of observations. It has 5 variables. That means it has 5 columns. Observations are rows, variables are columns. So 5 columns, like we just saw here. 1, 2, 3, 4, 5. In total, it has got 150 rows or 150 observations there. So that's just what is given by our console here. And structure will give the structures of, for example, sample length is in numerical. Everyone, sample length is numerical, sample width numerical, petal width numerical, and species is in factor. The species, which is, you can also say categorical or factor in R. So it's better to call factor. So species is factor, rest are all numerical. That's it with the structure. And structure also gives overall idea what analysis that we can do. So numerics are given at different levels. Like it's saying that you have got 5.1, 4.9, 4.7. It's in descending order. 5.1 is the highest petal length. 4.9 is the second highest on the bit. And if you look at the petal width, then you have got 0.2, 0.2 on the bit. And if you look at the species here, the factor, it is saying that you have got 3 kinds of labels, 3 labels. So that means the species are 3 species: Setosa, versicolor, and there's one more species called as Virginica. So we have got these things from structure. Let's try to, we can get back to this data exploratory of my data. Let's get back to hit my data. So hit my data will give you the 6 first observations or first rows of the data. Hit my data. So just type hit my data, and then this one is, and it's like I said, it's going to give you first 6 readings. Sample length, these are the variables or columns, and you are reading the first 6 hits. 1, 2, 3, 4, 5, 6. So this is how it looks. You must have also imagined, if you are looking at hit, you should really be also concerned about tail. So we can also do tail my data. So tail my data is last 6 readings. Control enter, and again we get last 6, 145 to 150, last 6 readings of our data through tail. Sometimes you need the names. What are the different kinds of like variable names that we have in my data? It will come through a function called as names, N-A-M-E-S, names, and you just go to again my data names. So in console, it's showing that, okay, you have 5 different kinds of column or variable, and the names of these columns are sepal length, sepal width, petal length, petal width, and species. So this is how you can generate here. Then let us look at attributes like here. So right now we just looked at the head, tail, names, view, structure. But if you are using attributes function, then you can actually directly look at everything else at once. So look at this one, the attribute results. Names are given, class are given, and the rows is given. So row names are again given. So attribute function is also one important function that we want to explore. Okay, next we are almost coming to the end of the exploration of the first basic exploration of data. We can also do FIX fix. This is specifically useful if you want to fix some of your data. For example, in my data, if I do not like a few of the data, or a few of the data is quite outliers, and if I have to remove it, you can remove it. And okay, so fix is to fix the data basically. The good thing about R is that the meanings are quite straight, and you do not need to complicate the meaning. What is fixed? Fix is just to fix the data, and just click it, and the fix will come out like this. If I do not like the name of status, or let's say sometimes I forgot to write the name of the status, the species status with, let's say, specifically the column 1, I just missed E. Let's say we can always write it through here. So now if I have missed E, I can always write back E. If the petal length of the first one is different and I would like to change that one, if it is 3.3, I can also change from here. So this is one way to change your data type values. But sometimes if you have to again, let's say sometimes if you have to add, let's say the sepal length is, okay, sorry, my screen is being controlled by key string. Stop control, okay. Where was I? Okay, I was in the fix. Okay, I was here in fix. Sometimes this is quite important again. If you want the sepal lengths, right now it's in numerics, but if you feel that you have coded the sepal lengths 1, 2, 3, or let's say that species name is being coded, sepal is 1, then Virginica is 2. And so if you have coded that one, and if it is coming in numerical, but if you do not want the R to read that as numeric, but that to be read as categorical or factor, I can always go to species and click like this, and I can always change from here, character or numeric. Right now it's character, so I'll just leave character. You can also change from here. So you can also do that. Let's say that now we have got fixed, we have fixed all the data. And let's say, I think all the data, they looks fine, perfect. Let's just go ahead now. Okay. Okay, so let's just go ahead now with next one. So the next one that I have is summary. SUMMERY. Summary is one of the functions to summarize my data. It will give us the result in maximum, minimum, quartiles and all. So I'll just like to summarize my data. Okay, the result is this one. So if I look to the console, I've got sepal length, different summaries, and species. There are 3 species. Setosa is 50, versicolor is 50, Virginica is 50 again. So this is one kind of summary that you'll be getting. There not be a discrete statistic summary where you need kurtosis, skewness, standard error. These things will get slightly later. So this is all about summary. And now The last thing that I want to teach you is the attach function. Everyone, please type attach. Attach, A-T-T-A-C-H, attach. And the good thing about attach is that it will attach the data set that you're going to work with throughout. And if you do not do that, you every time need to specify your variables. So I'm not attached right now. Let's not attach. Let's just see the disadvantage first. Okay, so this is the very basic exploration that you can do by the base R's function. So you do not need any packages to be installed to use these functions. These functions are all from the base R function. So that's the advantage of having these kind of functions. Okay, let's say that now I do not need to look at the iris. I need to now look at the data called as empty cars. Okay, everyone, let's go to empty cars. Empty cars. This is also one of the default data set given by Arla. And I'd like to now just replace my data, which is iris, but now it should be empty cars. Now I'll just see that it's empty cars, my data, no more iris, my data. So I just need to do like this, and everything is now set. I don't need to do anything else. Control and enter, you will see everything else. So I'll see structure, I'll see heads, and this is the advantage of setting the objective level. So at a go, you're getting all these functions together. I can just say, just select like this and run it in a go. So I'll be just getting all the things which I just got. And if I do not want to look at the empty cars, but I'd like to look at some of the data, for example, like cars, I can also do that. That's it with exploration. So this is advantage. One of the best thing about R, that we are allowed to set objects to our data. So can I also try this one? So this is the first part of our exploration. First part of exploration. Anyone having any doubt so far? If he's having problem, it shouldn't be giving us problem because these things are straightforward. Later part, if it is giving problem, then we would like to look at it in more detail. Sure. Strings are sure. We'd like to keep the recordings. Any doubt? Anyone? Any doubts? You'd like to move on? If you have no doubts, you have 10 minutes. This is done exploring the data through functions like assigning objects. We assigned objects. We looked at the view function. We looked at the head function. We looked at the 12 function. We looked at the structure function. We looked at also looked at the summary function. And I think that's it. Even attributes functions. That's it. The exploration. So you must be getting confused with the summary and structure. STR is just to look at the structure of the data, whether these data are numeric or categorical or factor. Then summary is to summarize, to give our maximum, minimum, and all those things. So far, so good, Mosla. I think it's slowly going to swim deeper. Okay, looks like so far it's so good. So I'll just like to check these things, make you all satisfied. Okay, now let's look at, before the lunch, let's just look at descriptive statistics. Everyone, descriptive statistics. Let us just try to get overall idea about our okay, so I'm going to do with descriptive statistics, everyone. descriptive statistic now. Okay, share. Now the second part is called as descriptive. Oh, descriptive statistics. Okay, and I'll just make this as comment. Okay, few descriptive statistics that we couldn't find there. Let's say that we want to get the mean of, let's say we are working with the data, let's say we are working with the dataset iris. So mean of iris, and specifically which mean do you want? And this is shown by $sign. So we're going to use the data called as iris. Inside the data, you saw that there are 5 columns: sepal length, sepal width, sepal petal length, petal width. I'd like to look at the mean of, let's say, sepal length. I can click here also. I can write also sepal length, mean of sepal length. So can you see the use of $sign here to specifically take out which column that you want to specify? Okay, so the mean of sepal length is 8.584333. That's the mean. Let us look at the same thing. Let us look at the median of, again, iris, and specifically which one? Again, sepal length, and control enter. Median of iris is 5.8. Let us look at the standard deviation, SD, of, again, the same thing, iris, $sign to specify which length. Standard deviation of iris is 0.8280. If I want to look at the quantile means different at different intervals. So what is the, for example, what is the 20% of the data for sepal length? So that's quantile, may not be used every time, but let's just use it for our practice here. Iris, and I'd like to look at length, and I click. So it's showing the quantile 0% null, 4.3, 5% anyway. So this is the quantile. So that's it with the descriptive statistics that we couldn't find there. Now I'd like to again show the advantage of attach. So if you remember, we looked at the function called as attach, and because we have not attached our iris data, we have to every time assign the $sign of attach, $sign after iris to specify sepal length. But if you are attaching, let's attach iris. I've attached iris. Now, whatever things that I'm typing is coming from the iris. So I can type mean. I can directly type sepal length. So sepal length is coming here. Okay. I can type median. Now I do not need to use the $sign every time. So I can type the median and median of sepal length. I can type the SD of sepal length again. Sepal length, okay. Then I can have quantile and all. So this is a wonderful function of attach. You're attaching the data here. Okay, so that's it with the few of the descriptive statistics that we have just missed with the exploratory part. Okay, about attach. Okay, in doubt, I think it's clear mostly for so far. So now, clear. Let me know if you're not clear. We really need to be clear. Moving on. So, okay. All right. So you can now play with the my data, or like any kind of like assignment of object to all these things, and you can play around. For example, let's just say that mean is called as mean. For mean is called as mean of iris or sepal length or anything else. But now if I type mean, then mean will directly give us this kind of value. So you can try to explore assigning of objects. And if you're very clever enough, you'll try to play with the objects every time. So that's it with the descriptive statistic. But before lunch, we'd like to explore the last thing for the day for before lunch. Okay, this is done descriptive statistic. We just looked at a few of the statistics like mean, median, and standard deviation, and also looked at I think quantile, and also looked at quantile. So I hope you are clear with mean. Just write mean, bracket no loop, specify that one, median, SD, and quantile. How to remove plus because the results are not showing. To remove the plus, it's quite easy. You directly delete the plus. If I've written something like plus here, and directly delete like this. Plus, directly delete it. So nothing to worry. Yes, definitely. Comments line are not properly ended. So try to check up your. Try to check two things. Try to check two things. Number one is the brackets if they are complete. Number two is whether there are plus signs, because plus sign is going to give us some problem here. Two things, okay. Okay, should we proceed, everyone? The last thing that before we move on, after lunch, let's look at visualization. Let's look at graph and all. Overall statistics, we'll just look at overall statistic given by one of our installed packages. So let us look at overall statistic, meaning specifically a descriptive statistic to come all these things together. Descriptive statistics, like even including standard deviation, skewness, quartiles, and all that. So I'll just share again. Okay, this one is overall descriptive statistics. Okay, I'll make this comment. Okay, so to have overall descriptive statistics, you need to load a package called as psych, PSYCH, psych. If you are facing problem writing library and all, you can always go to the packages in the right bottom corner and directly click on to these are all alphabetical order, so you directly click on the cycler. The reason why so many things are checked in my case is because the tide reverse has lots of packages with it. That's why. Okay, we need psych for this one, everyone. So go to library and type PSYCH psych. Then we are good to go with overall statistics here. So now let us look at describe. So if you have installed a package called as psych, you can see that describe is here. And specifically, I can see that inside my curly bracket, it's saying that this is a function of a package called as PSYCH psych. Okay, then I'd just like to look at iris. So I'd like to look at the descriptive statistics of iris. And that's it. Just control and enter, and we are getting so many good information, good statistics about iris. So we are getting variables, then we are getting population, then we are getting, there are 5 variables here, then there are 150 observation, and then mean for sepal length are all given, and median for all are given, framed values given, maximum minimum given, skewness, kurtosis given. So that's it with the descriptive statistics. Okay, finally, before going for lunch, how to export this descriptive statistics. For example, we got all these things left, mostly, and we got all these things, and how to export now this descriptive statistics. To do that, there are two functions. First one is read.csv for reading or importing, and for exporting, write.csv or write.table. Read.table or read.csv is for reading, importing, but if you're exporting, then write.table or write.csv. So whether I want this table to be exported in CSV or normal table, that depends on how I write now. So I'd like to write write.table, and okay, write.table, bracket opens, and there are two things that I need to assign here. Please do not get confused, everyone. There are two things that I need to assign here when I am exporting them. Two things, only two things: the data that you want to export and the file name that you want to export the data. So let's say that the described statistic is under an object known as results. So described statistic means result. We'll just enter, and it says in console that, okay, it's successful. Results means now described statistic. Okay, write.table nalu. The data that I want to export is result mostly. Comma should be always be there, because actually comments, between two comments, you need to always separate that with comma. So that is result followed by with what name do you want to export. So right now I want to export in a file name called as first.csv. So I can do that. But remember, I'm writing string, a very strange string or text. That's why you always need to keep it this inside quotation mark. So first.csv, CSV is a file format that I want to export. And it's important that sometimes you write separator. I felt it's important that sometimes you write separator between all the values. If not, all the results are coming in just one column. So separator SEP equal to I'll use comma. So again, comma should be inside inverted comma. So I'm using a data called as results. I'm naming that result, which has to be saved in first.csv, and the separator is comma. So right after I control it, okay, it's saying that it's successful now. If it is error, then there will be information about error or warning. It's successful. The question is, where will the first.csv be saved? It will be saved inside, specifically for me, inside our learning, our training folder. Let me check. Let me just check. Let me just check. Okay, so I'm going to our training. Inside that one, okay. I think right now there's notes. Write.table first.csv. Okay, I think if it has not reached there, then it's the problem of not getting things properly, because like I said, you need to restart. Maybe probably I think I've not restarted. That's why. Okay, so never mind. I'll just restart. I'll just save everything else. Okay, save. Okay. I'll just save my working file somewhere else. I'll just restart. Okay, save. I'll just open this one. Okay, and let me check out. Just run everything else once. And let me just, actually you do not need to run everything else, but just to make things clear for the class. Okay, so it's running everything else. together. You do not need to run everything else. For this one, I just need to run a library psych and directly describe these things. It's coming like this. Okay. It's okay. Yeah. So these things should be now saved in my. Sorry. Sorry, I couldn't show the screen, but the main thing is that the result has been saved in the folder called as R training, and here result has been saved here. So this is the results for R training. So please try yourself during the lunchtime and let us know how you felt. Let me look at the comment and. Yes, need to load psych. Okay, so that's it before the lunch. And please do not miss the after lunch session because the main session is on ggplot, how to explore different kinds of data interface with ggplots. So please do not miss that session. So far, so good. Thank you. Back to you, Dr. Jimmy.
So thank you so much for this very interesting session. Maybe we have 5 minutes. If there is some specific questions, then we could take. Otherwise, if there is no question, I think we will break for lunch and we come back by 1:15. I think some of them could not load the site library. I think Suraj Pradhan, maybe, but I hope you have installed.
But the main thing is that during lunchtime, please install the lunchtime if you can install the packages. You may start with descriptive statistics. Sure. Why not? Jumbo Gelson, sir. Why not? This is not a normal training. This is abnormal training. That means we would like to make you very comfortable with R. Sure. Pasandoji, sir. Please try right after lunch. I'll send all the codes to the email that we are together. Code demos la. And code this car. And code this la. The good thing about R is that you can copy this one, and the good thing about R is that you can copy the codes. And let me just share. Okay, sorry. The good thing about R, let me get back to again the good thing. Good thing about R is that I've just copied Musla. So everything is here. Everything is here, basically. So Anidi, I can directly, then I can copy. So next time, if you're doing master's or PhD or degree, you run all the codes together. Your supervisor or your teacher is just going to see the codes. So I've just pasted here, and he or she is just going to run the codes. That's where he or she is going to get all the results that you have just worked with. So I've just pasted all the codes now. Paste all the codes, and all the codes are coming here. So I think first session. Should we have to save all the R window codes? That depends, because even if you want to save in desktop, that's on you. But later on, if you want to practice this one, you can do that. For example, like I'm just saving this one, the untitled one. I can save this one, and I would like to save this one in this folder called as my R forever. So, okay, my R forever is something that I'm going to email you, everyone. And my R forever day, I can email you, Carlu. And let me email in front of you all so that you all receive the email. And let me just email everyone so that okay, assembling crash course. And I think it was all here, but I'll reply to all and just have one. I can attach this one. It was in my official meeting and seminar R Nalu, R forever. Just use this one. That's it. You get the codes lah. So you just have to run this one, or you, if you want, I can also give you in Microsoft Word lah. But looks like I'm missing everyone else. Okay, I can directly I can directly send R forever codes to all of you, and R codes exploratory, and okay, you all get the codes lah. So I've emailed the R codes to all of you. Back to you, Dr. Jimmy. I think that's it for the morning session.
Lasso, thank you, everyone.
Yes. That's it.
What sign to use on combining variables? C la C. Concatenate but it is difficult to pronounce. Also, I say combine.
Yes, C is also for combine. Combine or concatenate.
Concatenate but I say combine. So it is easier that way.
Okay, I will see you all after lunch at what time? 1:15 imola, doctor.
1:15, yes. 1:15. Reconnect again.
Thank you so much. Do not miss after lunch key time. Thank you so much.